Rise and grind. I choose to wake up at 4:20 every morning to get a head start. But since it's so early, it's still pitch black. So some mornings might end up like this. Walking in a pitch black room? Yeah, that's a problem.
Hey guys.
That was a complete exaggeration. But yeah, sometimes I get up and it's still dark. There's been a few instances where I bump into stuff, but not to the degree that I've shown. And it sucks. And I know what you're gonna say. Why don't you just buy a nightlight or a desk lamp? And to that, I'll say, you're right. But I'm already too deep. And let's get to the design. Alright, here's what I'm thinking. RGB desk lamp. So it's gonna be an IoT RGB. What is this? Short shot. So for the design. So I don't know if you've seen one of these I don't know if they're desk lamps or just straight up lamps that sit on the floor. So the design is very minimalistic. And it's just that, this, and that. So something like this, and then the lights are shining in the back right here. And yeah, that's what I'm thinking. That's the design. It's not focusing right there. And it should look like this. I'll edit that in. But okay, so here's a small scale version while we test things out. I'm thinking that my IoT MCU will go over here. Pause. Hold on. What is IoT? So IoT basically just means Internet of Things, devices that connect to the internet. So smart washing machine, smart TV, your smartphone is an IoT device. Smart teas. Alright, enough of that. So I'll put the LEDs over here. I'm thinking maybe 40 to 50 pieces. And then some type of plug for my power supply in the back. For the power, I won't be using these small tiny batteries anymore. They just wouldn't cut it. I need to be replacing them probably once a day if I use a battery. I mean, I could use a car battery. Nah, we're going for minimalistic, not big chungus. So for that, I'm gonna be using a power supply. And since I'm new to this, I'm gonna be using some extra protection. I'll use one of these things, this protection right there. And if that doesn't work, then I got one of these bad boys. So this is the backup for the backup. That's rule number 1. Have a backup for the backup. Or is that rule number 2? Because rule number 1 would be have a backup. Alright, shut up. Let's get to the build. Everything was going great until... If you didn't notice it, I was trying to solder these two LEDs and one of those wires slipped. And it's just... I can barely do one. Imagine me having to do 50 of these. I would go absolutely insane. Like, I can't. This is a US quarter, and this is the LED. Look at the size difference between these two. The LEDs are extremely small. I am not going to be using those LEDs anymore, so I'll transition to using one of these. This is the same part, but just more of them are clumped up together instead of just individual ones. So I have 5 of these. I guess I'll just have to solder 5 of them. Easy. And if that doesn't work, then I'll resort to this one. This is 60 LEDs. I don't think I would need 60, but I can just cut it up if I need it. Rule number 5, have a backup for the backup. Alright, back to the build. So, here's the prototype. I know it's kind of ugly right now, but that's alright. It's just for concept. I just realized that I bought 100 of those LEDs, so I might as well use at least one of them. So yeah, this is the current setup. The Node MCU is acting as a web server where it's serving an interactive web page, which allows me to turn the desk lamp on and off. Let's give it a try. On.
That's awesome.
And yeah, so this is only available in my local network. So only devices connected to my local network can access this web page. Now that we got the prototype working, it's time for the side quest. I have a lighting problem. I've always seen those vanity ring lights, and I thought, why don't I make one of those, but smaller? I'm gonna need some type of ring, battery, some LEDs. More LEDs means more soldering. I used up my last 2 brain cells and came up with a genius idea. Breadboards. The concept of breadboards. You can insert and remove wires pretty easily, making it solderless. So here's the design. The idea is I can just slip in the wires of the LEDs in these small little holes, and then the slit right here is where the power and the ground wires would go. So once I put the wires, I slip in the LED wires. They're basically in contact now, and I no longer need to solder them. And what's better is that I can choose how many LEDs I can put in here. So if I put 12 and that's not enough, then I'll put 24. And if 24 is too much, I'll just keep on reducing. And yeah, let me just grab it real quick. Ooh, look at that. Actually turned out pretty good. Cool, so I guess it's time to assemble everything. So the game plan was to start with 12 LEDs, and once we got it working, see if I need more. And looks like we're almost done.
Bottom is ground. So do this, boom, boom, and boom.
Don't mind me. I was sick for a week and I was just genuinely happy to be working on this again. So after integrating everything, it looks like this now. I know, it doesn't look safe, but trust me, it is. So the way the light mounts is it goes on this slot where the camera flash should be. It's awesome. It allows me to film at night and just like point at things and be able to see. It's nice. Alright, so back to the main quest. So the extension cord is plugged directly into the socket. The Node MCU and the LEDs are connected to the power supply. The Node MCU then connects to the LEDs for control. Then the Node MCU serves a web page where I can access it via an internet browser. For better accessibility, I think I'll just create my own Android application that can send commands to the Node MCU. So when I flip the switch, open the app, turn up the brightness. Wait, that's not supposed to happen. Wait, abort. Oh, this is so stupid. Alright, no more jokes. Let's wrap it up. So here I'm just soldering the 5 LED sticks, and this session took about 2 hours. So that's why I hate soldering, because it takes too much time. Also, it annoys me so much. I'm so bad at it that it's annoying. Okay, I think my soldering iron is broken. The gist of the problem is that only one side of my soldering iron can melt the solder. So I have to like twist it multiple times to find that sweet spot, and I'm like 80% sure that shouldn't be happening. Alright, I just finished soldering everything. Time for testing. Yeah, that's not supposed to happen. I'm trying to just light up one color, and yeah, that's not one color. There's definitely a problem. Okay, so I'm an idiot. Problem is, well, there's not enough power. Imagine you're trying to shower, but you only have a liter of water to shower with. So you get all wet with the water, and then now you're trying to put on soap, but you're out of water. So your day is ruined, and you're pissed. And that analogy doesn't make sense. What the fuck? Alright, so I was wrong. The problem is we don't have enough voltage. So this is a common problem with ESP32s. Essentially, ESP32s can only provide 3.3 volts, but the data input of the LED needs 70% of 5 volts, which comes up to 3.5 volts. So I'm like 0.2 short. That's why when I try to change the color, it just gives me a bunch of random colors. The solution for this is using a logic level shifter. Logic level shifters allow you to go from 3.3 volts to 5 volts or vice versa. 5 volts step down to 3.3 volts. So I did the change, and would you look at that, it's actually working. I'm currently toggling between red and blue, and yeah, it's working so far. It's amazing. So we finished the software, we finished the hardware, we're finally ready for the demo. Let's do it. Oh, that? So I found out that the last LED stick doesn't work. So I bought a new one, resoldered it, it works, crisis averted. So while testing it, I realized that the LEDs were a little too bright. So I printed a couple of diffusers so I can look at the LEDs and hopefully not go blind. Demo time, let's go. So the first effect is static. I'll go ahead and turn it on. Boom. Look at that. That's actually pretty cool. So this basically controls the brightness. So the brightness goes from 0 to 10, 0 being off, and then 10 being full brightness, and then you can also go half, and so on and so forth. For this demo, I'll just turn it up to full brightness. And the first feature is this. Basically, you can choose your color palette. Let's try red. Boom. Kind of pink. So it shows a little bit to the pink side. This next one is called Rocket Launch, or kind of just looks like fireworks going up. I like this one. Then we got Pulse. So it's like a heartbeat, I guess. Heartbeat, pulse, both the same. Then goes Strobe. This one's good for parties. Yeah, let's stop. This is making me dizzy. And then the rainbow. I love this one. Just look at it. It's just mesmerizing looking at it. It's crazy. And yeah, that's that's all of it. Oh, I also have this other functionality. Basically, you can time an on and an off. So right now, let's say I want to turn it off a minute from now. So 9:40, what? 9:48, because it just turned 47. I'll turn it off. There you go. Boom. And I could even close it. And it should turn off in about a minute. And with that, we're officially done. Well, I guess there's one last thing to do. Hey, thanks for watching. Oh, and if you haven't yet, watch this other video where I do another stupid thing up there. Click it. Please. Pretty please.